Hello, everyone. So thank you, Peter, for the training session. I am a model Dantec from the Technical Center IPC, dedicated to plastic and composite industry. And my colleague, Catherine Collin, will propose you the initiation to the safe and sustainable by design concept and the possibility to apply it to nanotechnologies. So Catherine is a program manager at IPC for environment and health, and so she's an expert on SSBD topic, and she will provide you all the keys about this concept. So Catherine will provide you this training, and then we will have a question and answer by the end of the session. So thank you, Catherine, and I leave you the floor to present.
Yes, hello. Welcome to everybody to this session. I could not be present with you because I will join a meeting in Grenoble in France tomorrow. And it's for a European project on safe and sustainable by design as well. So I will initiate you and explain you what's around safe and sustainable by design on a remote way. So this afternoon, we will see the definition and the explanation of this concept. What are the criteria called safe and sustainable by design? And after this, I will explain you what it means in practice. Is it a regulatory aspect? How to proceed if we want to apply safe and sustainable by design, or SSBD as we tend to call it. And we will finish by a specificity of this SSBD for nanomaterials with some introduction of possible tools, processes, and also studies that has been done specifically for nanomaterials on SSBD. So first, let me explain you what is the concept, what we call SSBD, and go step by step. To start with, I propose you to take a look at these global visions. It's called the planet boundaries. So the planet boundaries is a very good global vision to understand the environmental problematics, and it helps to understand what is SSBD. It has been published in 2009 by John Rockstrom and other scientists. The purpose is quite simple. They establish how should we consume and use on every environmental problematic to keep in a regenerative principle. I mean, how can we keep in boundaries that are sustainable, that can last, and once they have done it, they proceeded for measures. So today, not every environmental problematic has been measured. Some are measured, and you can see that the planet boundaries limits are exceeded for 5 processes. Useful information and important information for our concept is that in 2020, an update of planet boundaries happened where novel entities were added, and it's specifically in relation with the SAFE concept. If you look at the status of these planet boundaries, you can see several things. I will highlight some points like climate change and biodiversity being major axes. If they are impacted or if they change massively, potentially other environmental problematic will be impacted or change as well. Since this planet boundaries measurement exists, we found or visualize that some are quite stable. For example, climate change tends to be quite stable in its measurement since we have a care and a measure of it. And you can see and understand as well that planet boundaries are established at global level, if you look inside some geographies, it could be there could be a high variation for some problematic like fresh water use, for example. So when we look at these planet boundaries, it helps to understand all of these criteria that are behind safe and sustainable. Let's take a look at safe concept or safe criteria. To make it simple, you can associate and memorize that safe is associated with health. So it means that if you are safe, you can tell I'm toxic free. It means that if you are not safe, it's related to an hazard, meaning a potential harmful effect either on a human body or another organism. So we speak here about really health aspect and some disease like cancer. It can be also reprotoxic, so very bad things, so very serious health concerns are behind the health concept. And this is what is measured with this criteria. And we take a look at materials, chemicals, or products in a term of their potential harmfulness. The talk I like to remind and spread for this is the one from European Commission members who told that chemicals are both a blessing and a calamity. It's for me, it's really speaking. It means that if you look at your own body, you also have toxic stuff inside it. If we would do chemical analysis, everybody would be both harmful and blessing. So it means that we live with such chemicals, substances, and toxic effect. It's the safe criteria is here to reflect how can we avoid massive health concerns. And the evaluation of the safety is associated with two aspects, one being the threshold, how much concentration of the toxicity you have inside what you look at. And another is the exposure. For sure, if you are daily in contact with a certain substance, it's more the exposure level makes it more harmful. So these two aspects are considered by the regulation around the safe concept. And you have here the example of the RUS directive for electrical product, which consider a threshold of 0.1% by weight. It means that if you are below this threshold, we consider that it's not intent presence and that you don't have the substance part of your material or article. And every regulation on safe is using these two aspects, threshold and exposure. On the safe concept, so the safe concept of SSBD itself, it was defined by the European Commission. The Joint Research Center worked on it and consider already existing regulation for safety. One is the Chemical Safety Directive called CLP, and another is REACH. So REACH is existing since 2006, and today more than 200 substances have been either restricted or authorized only in a very limited way to diminish the toxicity on the European field. On these two directives already caring about safe, the concept safe has two other aspects, one being more predictive to take care on intentionally added substances and also non-intentionally added substance, which can come from the contact with the substance of your material, for example, with a detergent. If we talk about waste and end of life, and certain mix can happen and can create this, what we call NES. The safe concern, as you can see on the graphic, is carrying both of the threshold and presence as well as the exposure. And it's a global look at the safe aspect, including end of life and production. Whereas generally, you look more at content in your ingredients, and care is less for production and end of life. If we look at concrete example of how to apply this safe concept and deploy a safe product by design, you remember, you know that since we have the pandemic, we have new policies, and we tend to deploy policies for cleaning and disinfecting, which is very good to care and manage the pandemic. On the opposite way, it has an excessive use of disinfectant, and we can create health concern for building offices occupants. So some example of created hazard can be, for example, if you look at bleach, you can, if you use it in increased levels, you can cause more respiratory issues and asthma, which is a concern for a large proportion of persons in the world. So using more disinfectant can create toxic aspects and health concern. And some industrial search solution and safe solution on this. You can see some example with UV technology or chemistry thymol, some natural disinfectant. So if you look at this solution, what they are providing is a safe answer. The functionality is here to disinfect, and we tend to search no harmful aspect on safe aspect. What you can see is we are not in an ideal situation. Even with oil from Tim, you can have some skin irritation if you use it in too large proportion, or if some people are very sensitive to its odor or its oil. Let's take a look at sustainable concept. So sustainable in SSBD is aligned with EU commitment. It cares about 3 major commitments taken by the European Commission. One is climate neutrality, another is zero pollution, and the last one is circular economy. Basically, what the European Commission would like to deploy and find with the sustainable aspect is to go for an acceptable level of sustainability, where we go for a regenerative growth model. Basically, if you look back at the planet boundaries, it would mean being within the boundaries and being regenerative, having a growth model which enable continuous agriculture and environmental benefits. The considered exposure for pollution or circular aspect are the exposure to air, soil, and water. All these aspects are considered to examine if we are in a sustainable model or not sustainable model. In the same way as for SAFE, can we take a look at example who practices this sustainable criteria? It does exist. A major field where it is being practiced is green buildings. So you have more and more in the world some building being constructed taking care of environmental performance, and some rating system have been developed. The most used in the world is the LEED rating system. It's a US rating system model. You can see that it's already considered sustainable criteria with a global vision in the same principle as what the EU call SSBD. you can see, for example, that there are some criteria and practical criteria rating energy and atmosphere, which is related to climate change. You also have some health concern via indoor environmental quality. You have some criteria caring about biodiversity enhancement and care of sensitive land. And you also have sustainable and the material criteria. You can see that there is a specific rating criteria caring about material and resources performance. So you can see that such sustainable rating are already practices, and some solution exists for specific fields. And if we combine together safe and sustainable, how we come to SSBD. So it's for the EU considered all the different aspects and environmental programs that has been deployed through regulation or framework or incentive. And from this, they define that it's very important to have a global criteria called SSBD, which is to come into a more preventive approach and being more predictive compared to caring on a side to safe and on another to sustainable, or taking each criteria one by one. So it's not, SSBD is a voluntary approach. It's, you can see it's not a regulation yet, and it's not planned now to be a regulation. It's more a framework and a guidance of the EU to proceed for toxic-free environment, include material manufacturers and recyclers during design stages, so that we care of the exposure and potential aspect around the full life cycle, not only during use or during design. And a global purpose of SSBD is to be able to conserve natural capital. You can see that the GRC deployed SSBD criteria defining a rating, and the wish is that an innovative solution with performing aspect on safe or sustainable problematics should be accompanied with such SSBD rating, so that it helps research and innovation going into their roadmaps. So I hope you catch some point on what's safe, what's sustainable, where does it come from, why do we set up planet boundaries, and what are the problematics behind it, and why the EU is suddenly expressing a new criteria, a new wish of rating called SSBD. Now that I described this, I will now explain you in practice how does it come to EU field, or what's the vision, or how to practice SSBD from a regulatory standpoint, as well as from an industrial standpoint. If you have a solution, what does it mean to practice SSBD? So there are SSBD is associated to several regulatory initiatives. One has EU policies behind or covered by the Green Deal. So it concerns all regulation related to biodiversity, circular economy, farm to fork, and zero pollution chemical strategy. So several regulations are make sense to come up with SSBD. Another international organization coming up with SSBD criteria and concept is United Nations. So if you look at the Sustainable Development Goals, they are frequently used in environmental and health policies of companies. You can see that several of them, you have 5 major goals which embed criteria directly associated to SSBD. And they also plan to have to avoid toxic aspect for air, water, and soil, care more about a regenerative growth model, and it's all described with global goals associated with specific criteria. A new point from UN is that in March 2002, so this year, they published a new resolution. They would like to have like an independent policy panel to care about safe and sustainable criteria in the same way as scientists care about climate change within the IPCC. So they would like to have more care about safety, sustainability through an independent body who would work and define a roadmap and a guidance to establish how we come progressively to safe and sustainable by design products. So these are the coming regulatory framework for SSBD. There might be other regulatory initiatives in other areas. They are not expressed in the same with the same stability or maturity as for EU and the United Nations. So that's why I use here to describe you the SSBD scoring system. I use the one prepared and established by the European Commission. So it's important to understand that it's progressive. You will not be SSBD from today to tomorrow, and the purpose is not to be SSBD OK or SSBD KO. It's not so ideal. It's a ranking system which goes with value from 0 to 5. If you are at 0 and low, it means you had a bad score, and an excellent score would be 5. The ranking is going through several criteria. 3 are related to safe, caring about different cycles of the product, the design and formulation first, then the production and more processing aspect, and use and exposure safe aspect associated with the use of the chemicals or product. And the 2 last rating points are concerning sustainable criteria and social and economic criteria, because EU considers that there is no point in deploying a safe and sustainable product if nobody wants it and if its price and economic situation is not viable. Therefore, the 5th criteria on social and economic aspects. So as I explained, and as you can see, it's a loop where you do follow some design guidance. You do a first assessment of safe and sustainable, and you have an initial score that you can rework or improve. And the purpose is to progressively come up with some products on the market which will more answer to this criteria. The ranking system is still a theoretical ranking system. Today, the European Commission is on a stage where they do evaluate 3 case studies. So you can see that they have selected case studies for food contact materials, for textile, and for flame retardant used in ICT products. So very specific situation or solutions where safe and sustainable ring a bell, but it's not exhaustive. So they are very willing to get more case studies from the field, some innovative solution, European project coming up with case studies, or industries coming up with case studies, they want to use this field feedback to refine their methodology and confirm how do we SSBD by design, how do we design with this purpose. If you take a look at the ranking criteria, it means already 5 points, many ranking aspects behind it, how to proceed. So if you are if you have an innovative solution and you are asked to go for SSBD ranking, it means to collect data along the life cycle. And if you are producing such electrical panel board and you want to know if you are safe or not, or sustainable or not, it means going up to very small substances coming up from your materials and your articles. So a lot of data collection among your supply chain with exchange and the collection of information from your suppliers or manufacturers. So it's always a balance between use of generic and specific data, because in some cases, every panel board would be in the same situation and with the same answer. So generic data are fine for such situation. And in some cases, if you don't know who produced, what is the location of production, maybe some specific data are useful. So you can see that there are some practices to rate and collect information to understand if you are safe or not. Generic or general used procedure are to collect declaration from the supply chain, which can be also collected via doing laboratory test reports if information is not known and declared by the manufacturers. Safe experts are very useful in this process because they can tell you among your bill of material, among your materials, where are risk, what presents, what point can concern either safe or sustainability criteria. And another way to practice it can be to define that you will only buy certified materials and components, for example, cradle-to-cradle certificate products or health product declaration. So you can also decide that you select an environmental label that your full supply chain will have to follow to be sure that you have 100% safe constituent in your product. So quite a lot of work, exchange, communication, and data needed to be able to do this SSBD ranking. The last part of my presentation is to take you on a run tour around for nanomaterials and to take a look at how to practice what does mean SSBD, safe, sustainable by design for nanomaterial, what was already experimented, and how what tool, what practices are identified. So for nanomaterials, two domains are more experimented than others. It's food packaging and cosmetics. They provide some ideas and guidance to go for SSBD. For example, it's they recommend to use less hazardous nanomaterials as nanocellulose, for example, to go in much more interdisciplinary design, do some biomimetics, mimic the nature, and avoid some formulation where you select chemicals that can be of concern in your starting agent, in your solvents, and so on. They also deployed some approaches which enables to go step by step in investigating and designing, understanding if the selected design is aligned with safe and sustainable criteria. And they also worked on the fact that first, the first point is to reduce hazard, and the second point is to reduce exposure. It's more important for nanomaterials who have worked on SSBD to reduce hazard and go searching for new innovative solutions that directly answer to the concept. A specific problematic for nanomaterials and SSBD is for sure that the property of nanomaterials are changing and varying with time and conditions of use or environment. So it makes the rating more complex compared to other fields, compared to material rating, for example. Teams that have practiced SSBD for nano deployed interesting simulation and modelization tools. So there were several European collaborative projects which deployed assessment tools or what's called computational toxicology. So you can see several projects and tools that has been developed. The principle is to do some molecular dynamics simulation. They key in all the chemicals, the substances included in the formulation. And these molecules and substances are modelized in the tools. Possible interaction are calculated, and it gives an indicator or a results telling to the designer how much harmful substances can be obtained from this design. So it's requires quite a lot of computation and powerful calculation, and such tools are very helpful to understand non-intended interaction or potential interaction between the selected molecule and substances for the design. Another example is process workflow. Here, it's not about modelize what can happen in terms of safe. It's more to investigate the design and define a process where during design, you progressively collect and check all criteria related to SSBD. So it does list in an homogeneous way what do you need to collect and check, what is your checklist to be able at the end to have an assessment and to identify what are your uncertainties, what question you should keep concerning SSBD. The point of such workflow, or what we have through such development, is an harmonized workflow where every industry deploying similar design can use the same rating process. In a similar way, some nanomaterials teams deployed a possible process to design SSBD nanomaterials. So they described what is the design process if you want to be SSBD. And it concerns first the properties of your nanomaterials, a check around use-oriented properties, defining limit values. Once these design stages or concept stages are defined, an additional stage is collecting of information, where the data collected are helping to build two files, a safety dossier and a safety profile. Both will accompany the nanomaterial design through its life to make sure that we can demonstrate and track back how SSBD rating is at. It's not enough. Teams who practices SSBD by design have all told and identified that information and communication is between stakeholders is very important. Therefore, a massive highlight on dialogue, talking to experts, collect information, and harmonize criteria exchanges to rate your status for SSBD. And this is why some work done on SSBD for nanomaterial came with a very important concept called trust environment. It's not easy to control and reduce your regulatory uncertainties. Are you safe? Are you sustainable? It raises many questions. And it's not easy to pass to authorities a file which states where you are at and to feel comfortable with it. So the trusted environment approach, which was described in a publication of 2018, described an ideal information platform that would be independent. It would allow to create communication within a community with easy access to experts, knowing some piece of information on safe or sustainable criteria, where there would be no fear to proceed for questioning, answering, because you would know that the question you raise or the information you share on the platform is protected and that there is a certain data knowledge and data control on what information is shared with what interlocutor. The database would also include the certainty that if you provide information or if you raise a question, you would not be pointed out by an authority because you don't know if you have a safe concern or a sustainable concern. And you could also use it to gather and easily and quickly find information such as what are the typical substances or safe question for such design, and have a forum with quick interaction and access to specific expert concerning your point of view or your design. On top of this, for sure, such platform would be a benefit for nanomaterials designers or any designers facing SSBD if you are valued when you participate, meaning that if you go and use this platform, it's like a global community. You are not suited or you are not controlled. The purpose is more to facilitate the access to SSBD information and accelerate answering, meaning is that if your question is already addressed and every expert knows the answer, you don't have to find it on your own. You can benefit of already known scientist knowledge or regulatory knowledge on your point. Several European projects or international projects are going through this trusted environment project. You have here example. Several projects are starting. All these projects are starting since 2022. So there is IRIS EU project, Surpass project, PARC EU project, and also this United Nations resolution willing for an independent scientist panel caring about safe and sustainable. So you can see that on top of technical and environmental safe criteria, what's important in SSBD by design is also the creation of community access to experts and facilitating access or development of a safe and sustainable by design products. This is the end of my tour on this safe and sustainable by design concept. I hope you could follow my tour and catch some points. And I'm ready to guide you or answer to the question you have.
Thank you very much, Catherine, for this presentation. Do you have a question to Catherine about SSBD and how to apply it to nanomaterial and nanotechnologies? No specific question. No question online too. So I think yes, SSBD is a new concept we have to apply and to also follow what European Commission provide for the framework. You mentioned that the existing framework is still on construction with the GRC work. I think it's we will know a little bit more, but thanks to your presentation, we have some clue to work on it on nanotechnologies. So thank you very much.